For the second part of section 2.4, we're now going to discuss operations on complex numbers beyond just powers of I. So in this case, we will be discussing adding, subtracting, and multiplying. Division takes a little bit more work and is not something I think is super important to cover, so that's not something we will cover in this video. All right, so to begin with, let's just do an example, and this is going to pretty much cover all of these, and then we'll end with one other key concept for complex numbers. So we're going to let one complex number be the number 5 plus 8i, and then we're going to let another complex number be, let's do 3 minus 4 times I. And we'll be using these throughout the next few examples. So the first one is, let's go ahead and add z1 plus z2. And so all we're going to do is take 5, I'm going to put them in parentheses. Here, let's color code this just a little bit. I'm going to put them in parentheses like I was saying, although it's not really necessary. But this would be 5 plus 8i plus 3 minus 4i. And this works the exact same as if you were just combining like terms. So we would take the 5 and the 3 portion, the real parts, and add those together. And then we'll also take the imaginary parts and add those together. So my answer will just be 5 plus 3 is 8, and then 8i minus 4i is just 4i. And so this would actually be my final answer. Pretty straightforward if you're familiar with combining like terms. Similarly, if we did subtraction, let's do z1 minus z2 now. It's going to be the same idea with one minor exception. We do have to be careful with our distributing. So I'm going to take my numbers here, 5 plus 8i. I'm going to go ahead and subtract 3 minus 4i. Now keep in mind, this subtraction does have to distribute to each term in parentheses. So I'm going to end up with 5 minus 3 as my first part, and then plus 8i plus 4i, not minus. And so I end up with 2 plus 12i as my final answer. Again, this is combining like terms. However, be careful with that negative sign, just like you would with x's. Now the final operation we're going to do is multiplying. So I'm going to take z1 times z2, and this should again look familiar. So 5 plus 8i times 3 minus 4i. We're going to do this exactly as if these were x's instead of i's. So this would be distribution, or some folks might want to call this FOIL. But what it is we're just going to take the 5 times 3, 5 times negative 4i, and the same with the 8. Let's go ahead and write all these terms out. 5 times 3 is 15 minus 20 times I. 8 times 3 will give me 24i, and then 8 times 4 is negative 32. But notice I do actually end up with an I times I, which is I squared. So now the next step is going to be to combine like terms. I'm going to take the i's and combine them. But this is where it's slightly different than what we would have if this was an x, because I squared, remember, in the previous video, actually equals negative 1. So before we go on to the next step, let's go ahead and let's rewrite that. It's negative 32 times negative 1, which is actually going to be, here I will start to combine some like terms, but that's going to actually be plus 32. And then minus 20i plus 24i. I've also rewritten it because now I realize that that last portion was a real part, and so I need to go ahead and combine those like terms. So 47 plus 4i will be my final answer. Notice that this is just another complex number. We haven't somehow left the complex numbers with I squareds. We still have a number in the form a plus bi. So this is still a standard complex number. Now, the last thing I want to define with complex numbers is something called the complex conjugate. And this kind of relates back to multiplication, so that's why this is stuck here, because it will be related to what we just talked about. But what I want to mention is if you are given a complex number, let's call it z, and we'll just do the general form, a plus bi, then its complex conjugate is given by, we use z to represent we're talking about the same number, but we put a little bar over it just to show that it is related to the original, but it is the conjugate. And so its conjugate would be a minus bi. So notice complex conjugates, the sign switches for the imaginary portion. Now, the same goes for the opposite way. So if you started with a minus bi, then the complex conjugate would be a plus bi. Now, here's why this is useful. If we were to multiply a complex number by its conjugate, so let's go ahead and multiply a plus bi times a minus bi. Notice that we would end up with a squared minus abi plus abi, so those will cancel. And then we get minus b squared I squared, which actually ends up giving me a squared plus b squared, because the I squared is -1. Let's go ahead and color code this a little bit. So the I squared equals -1. This middle part equals 0, and so I'm left with a squared plus b squared. Now, this is a formula you might want to actually have written down. So if you multiply a number by its complex conjugate, you can just square a and b and then add them together. For example, let's say we want to multiply, we'll do a couple of these. So we're going to multiply the following numbers by their complex conjugates. Let's go ahead and start with the number 2 minus 3i. So to begin with, I am going to write down the complex conjugate would be 2 plus 3i. And let's go ahead and multiply. So 2 minus 3i times 2 plus 3i. You could distribute everything, but we do have kind of a nice formula. So this is just going to equal 2 squared plus 3 squared, which will be 4 plus 9, which would be 13. Now, what's nice about multiplying a number by its complex conjugate is that the answer you get is always a real number. And that's a note we could actually make in our formula. This here is always a real number. There are no i's in the answer anymore. Okay, let's go ahead and try another one. Let's say I had the number, this is a purely imaginary number. Let's just say the number was 5i. Well, if the number is 5i, that means its complex conjugate would actually be -5i. I'm going to switch the sign of the negative part. And then when we multiply them, we would just end up with 5 squared, which is 25. Now, there's obviously more steps you could put in here. I could do -25, and then it would be I squared, which is -25 times -1, which does in fact give me positive 25. But just know that when you multiply a number by its complex conjugate, you can use the formula to make things a little bit easier. There's one more that I want to do just to kind of remind you of something. Let's say I had the complex number -3. Notice there actually is no imaginary part to this, so this is actually a real number. That means that its complex conjugate is the same thing. It's -3 because I would have plus 0i and then minus 0i, which are the exact same. So then if I multiplied the two numbers together, -3 times -3, I would actually just end up with 9, and so that one's a bit easier to multiply than the other ones. But I just wanted to remind you that the complex conjugate of a real number is the same number. It doesn't change. And that concludes our operations on complex numbers. That really concludes our sort of journey into what you can do with complex numbers. This was sort of a side note from polynomials for a little bit. In the next video, we'll get back to polynomials and talk a little bit more about why we use complex numbers in this section, and we'll get back to our previous discussion of chapter 2.